Good evening, everyone. Welcome to Yale Alumni Academy's annual climate change conversations. Today is the third webinar in this year's series. Thank you for joining us. Please take a minute to introduce yourselves in the chat. Please include your name, where you're zooming from, and a little about yourself. We will be sharing the chat transcript with Dr. Chen, so he has a chance to review people who have attended tonight's meeting. And we'll get started in a few minutes. When you're introducing yourselves, if you can please share where you're zooming in from and a little about yourself, perhaps your Yale year or what brings you here tonight. We have David joining us from Murfreesboro, Tennessee. And Thayer Ung from the Western Reserve University in Cleveland. Thank you all for coming this evening. David Luckey at the Yale School of Music, class of '84. We have Cynthia joining us from Cairo, Egypt. Welcome, Cynthia. We have Carolyn, class of '85, joining us from Calgary, Canada. While you continue to introduce yourselves, I'm going to go ahead and introduce tonight's speaker, Dr. Kai Chen. Dr. Chen is an assistant professor of epidemiology at the Yale School of Public Health and serves as the director of research at Yale Center on Climate Change and Health. He is the principal investigator of the Yale Health and Environmental Nexus, or the Chen Lab. Dr. Chen is an environmental epidemiologist who focuses on the intersection of climate change, air pollution, and human health. His work involves applying multidisciplinary approaches from climate and air pollution scientists to exposure assessment and environmental epidemiology to investigate the impacts of climate change on human health. Dr. Chen investigates how ambient temperatures and extreme weather events such as droughts, floods, and wildfires can affect mortality and morbidity from a comprehensive spectrum of diseases, including myocardial infarction, kidney disease, childhood diarrhea, birth outcomes, unintentional injuries, and mental health disorders. He also assesses the adverse health effects of air pollution and their interactions with extreme temperatures from local to global scale under a changing climate. Today, we will be discussing climate change epidemiology. With the record-breaking hot summer in 2023 and extreme weather events throughout the world, one has to wonder, what are the health impacts of these climate change-related events? Leveraging multidisciplinary approaches and collaborations, a new field of climate epidemiology has emerged to answer this question. In this climate change conversations, we will discuss how to connect the dots between climate change and public health, using examples from recent work at the Climate Change and Health Environmental Nexus Lab at the Yale School of Public Health. Thank you for joining us this evening, Dr. Chen, and I'll turn it over to you.
Thanks for the nice introduction and invitation to give me this opportunity to talk with you about some of our work on climate change and health. It's my great pleasure today to introduce the field of climate epidemiology using our own research. So let me share my screen first, if you can see it. Okay, let me begin. So thanks everyone for taking your time. today, the European Companies Climate Change Service did just publish a new results showing that the passing November has been the hottest on record. As a matter of fact, if you look at the record, this summer and this autumn, they were the hottest season on record. So since June, we have seen this record breaking for each of these months. And it's very likely that 2023, we're going to see the hottest year on record. And with increased air temperature, we have seen all kinds of extreme weather events. For example, you recall the freezing wildfire in Lahaina in Maui that kills more than 100 people. And wildfire is not only just a Western Coast problem now. In June, in East Coast, we also see the wildfire smoke traveling hundreds of miles from the eastern Canada. And the weather attribution study did a rapid assessment shows that climate change has more than double the likelihood of these extreme fire weather conditions happening in the eastern Canada. And when we have high temperature, the atmosphere also holds more moisture. And with more moisture, it will have extreme rainfall in some places, but abnormal less rainfall in some other places. For example, last year in Pakistan, we have seen this deadly flooding event, and much of Pakistan was underwater with about 1,100 people died. And this year in September 2023, we have seen the most deadly flooding in Libya, which recorded more than 4,000 people died. In the same time, we also see drought events happening across the world. For example, last year, the largest fresh lake in China, the Poyang Lake, literally dried out. And Eastern European river, because the record low river level, we have seen World War II German warship revealed itself. So through this, we have seen that extreme weather events is happening. And what are the impacts on health? So conceptually, we know that climate change can impact our health through this extreme weather events directly, but also it can indirectly impact our health through worsening water quality, air quality, land use changes, or ecological system changes. And all these direct and indirect effects combine together and make it complicated is what's happening on our social dynamics, including the aging trend, the social economics, the health disparity, all combined together can impact not only our physical health, but also our mental health. So the climate health research field has more than a decade knows that climate change is going to be the biggest global health threat of the 21st century. So that's the statement holds true even after the COVID-19 pandemic. But you have to wonder, so how could scientists come to this conclusion? In other words, how do we know exactly how climate change could impact our health and attribute these health damages to climate change? Well, the answer is climate epidemiology. So at Yale School's Public Health, the Center on Climate Change and Health, here at the Climate Health and Environment Nexus, the Chen Lab, we aim to address that question, applying multiple disciplinary approaches from climate sciences, epidemiology, environmental sciences, exposure sciences, and machine learning approaches. We want to study and investigate the intersection between climate change, extreme weather events, air pollution, and human health. And broadly speaking, to answer that question, first of all, we need to know the study population you are looking at and what kind of health outcomes that are sensitive to the climate exposure. But obviously, we need to know what the climate-related exposure are and how they will change either, according to the different future scenario we're expecting them. But that's not going to be enough, because not only we need to know how the exposure itself changes, we also need to know whether or not these changes will bring the health damages. And the key to that is what we call the exposure response functions that are usually derived from the epidemiological research. And when you have all the pieces together, you can calculate the health impacts from climate change. And recently, the current trend of the topics in climate change epidemiology can be broadly defined into three categories. One is we need to know what kind of exposure that can be linked to all the health outcomes. And sometimes we need to find a way to better characterize population's exposure to these climate-related stressors that links to whether how spatially or temporally refined these exposures are. The second, a big effort is to provide these exposure response functions. In other words, how bad these exposures could mean for our health. And then the third part is we need to employ these climate simulations together with all the projections for the social economics, the demographics, populations, combining together to see in the future under a certain scenario, what are the potential health impacts will be. So in doing so, we need to incorporate all these elements together, and in characterizing each element, these incorporates a lot of uncertainties within them, which we will cover them later. So today, my talk, I think, to give you some examples, we will show from these three broad aspects: from first exposure, second of all, how we do this exposure response function, and then when we combine all this together, how we do this scenario-based health impact assessment. So in terms of exposure, we all know that, if you look at your phone, you will see how hot or cold it is for today's temperature. We also see the weather forecast regarding, for example, yesterday there was a forecast of flooding for the Pacific Northwest due to the heavy rain, right? So all these information we gathered are the climate-related factors. But sometimes when we need to study the impact on health, we need to have a very fine spatial or temporal resolution model for them, because the data we get, for example, the temperature data you get, is likely from, for example, airport monitoring station. And we know that the airport monitoring station's temperature data is going to be very different than where you are currently experiencing in your home, in your office, right? So how to better categorize people's actual exposure to these climate-related factors, mostly meteorological factors, we need what we call the spatial temporally resolved model. And nowadays, with the advances in machine learning approaches and with the availability of a lot of big data from either satellite images that we can get the land surface temperature or the different types of land use data, we can combine or fuse all the information we can get, and then rely on the power of the machine learning algorithms to model these highly spatially resolved air temperature and other meteorological exposures. So based on that, we can know historically of how people are exposed to the climate related factors. But if we want to project to the future, we also need to know how the future will be looking like for these exposures. So we need to rely on the projections from the different climate models. These different global climate models, or in other words, called generalized circulation models, they are developed to give us a potential future of what it would look like under certain climate, social, economic scenario. So based on that, we can, for example, in a recent paper, we got more than 800 around 800 cities around the world to know in the future what their temperature would be under two different climate scenarios. So these are just two quick examples showing how we need to do in terms of exposure modeling. But the major piece is actually coming from the exposure response function or the epidemiological research. For example, when we talk about heat waves, I think everybody knows heat waves are deadly, right? Because if you open to the news media, you can immediately capture their headlines. For example, these are the headlines we saw for the Pacific Northwest heat wave in 2021. So you can see, for example, the New York Times reported more than 100 people died in Washington State and Oregon, right? And so there are about hundreds of people died due to that Pacific Northwest heat wave event. But actually, the health effects of these abnormal temperatures, the impacts are more than just the heat waves. So when we have a heat wave, it's defined by the extremely high temperatures. However, through the past decades of research on temperature epidemiology has shown us that the health effects of temperature is way beyond just these extreme hot days or cold days. So when we have the what we call the exposure response function, you have the temperature exposure on the x-axis, and then you have your mortality or morbidity risk on the y-axis. What we found is there's a U-shaped relationship. That means when temperature goes too hot or too cold, people will have a significant health risk. And from this figure, what I did using about 8 European cities data, what we found is that the heat does not have to be reaching the 99th percentile temperature to kill people, right? So when it's even 90th percentile, 85th percentile, they can still have significant mortality risks. And because we don't live in these extreme heat wave cold spells every day, these not extreme, what we call moderate heat or moderate cold days are actually more often, right? So we have more days living with these moderate heat and cold days. So it turns out these moderate heat days and moderate cold days actually bring us way more health burden. So that's why what I call, when we look at the health burden or health impacts from the temperature, it is not just about the few days of heat wave. And if you look at the different causes of people dying or being ill from the heat, we can see that heat really affects a full spectrum of the diseases. For example, our recent research shows that being exposed to heat can lead to a significant increased heart attack events. And having higher summer heat can lead to stroke mortality risk increases. And the list just goes on. For example, recently, our study in New York State shows that heat exposure can lead to increased emergency room visits for kidney-related conditions, be it acute kidney failure, urologitis, or volume depletion. We see the increasing hospital emergency room visits when temperature goes up too high. And the impacts of heat goes beyond just the physical health. When we look at the mental health, first of all, we see the total mental disorders in New York State increases when temperature goes up. And when we look at the different categories, what we found is a consistent increasing pattern. So heat can increase the anxiety disorder, the mood disorder, substance abuse, or even schizophrenia. So in other words, heat leads to a common mechanism that driven these increases in the mental disorders. So what about the other extreme weather events? Recently, our study in the low and middle income countries using the demographic and the health service data shows that the long-term exposure to the drought conditions can actually lead to significantly increased childhood diarrhea risks. And the most severe drought actually will lead to much higher risks for children having diarrhea. And then when we look at the flooding events, we also see that the flooding exposure over a few weeks can also lead to this significantly increased childhood diarrhea risks. And the more interesting in this study, we found that if we have a compounding event, that you first have a drought event, and then you have a flooding event, the risk of diarrhea will be increased much more if you have this kind of flood and then the drought and then flooding compounding events. But the impacts of these extreme weather events goes beyond just the children's diarrhea risks. Actually, yesterday, our research published in Nature Water shows that the flooding exposure in North Carolina, in the United States, can also be linked to more than just this kind of communicable diseases. So what we found is a few days exposure to the flood, be it flash flood or non-flash flood, this exposure can lead to significant increase not only the accidental mortality, but also non-accidental mortality, such as cardiovascular disease mortality, respiratory illness mortality, and the significant increases, the largest increase we see is actually also from the mental health mortality. So it really shows us when we think about the flooding events, it is, if you recall the $1 billion disaster by the NOAA, that $1 billion disaster, they are only from the property damage, the economical causes. So when we think about these extreme weather events, what are missing is actually the health cost from these extreme weather events. And our studies, and I think many more studies will show, is that the flooding and the drought events, they have way more health damages than previous people thought. So it's not only about the people died or drowning during the flooding events. It is also by all the indirect health damages caused by flooding and drought. I think this year, if you didn't notice before, you must have noticed about the Wi-Fi smoke. Primarily, for example, in the East Coast, we have this extremely high level Wi-Fi smoke event episode. So in June 6 to 8, the New York City skyline really was impacted by the Wi-Fi smoke. Even here in New Haven, we not only see the orange sky, we actually smell the smoke. Although despite this smoke actually happening, was originally from hundreds of miles away in the Eastern Canada. And if you look at the air quality data, here what I show is data called fine particulate matter. The fine particulate matter is small particles that are smaller than 2.5 microgram meter. They are so smaller that they can be 1/20th or 1/30th of a human hair. So that means this so-called PM2.5 or fine particulate matter that typically are invisible. But when you have so high level of PM2.5, then they can actually affect our visibility. So that's why when it goes up too high, we see the orange and blue, the orange sky in the New York City. And this just shows that during this extreme smoke wave period from June 6 to 9, we see these all of a sudden increases in the PM2.5 levels. And you can see here in the value of the PM2.5 normally, it should be around below 10, but now it can be above 150. So this is really a very significant effect. And when we look at the health impacts, what we see is that during that smoke wave, there was a spike in the asthma-related emergency room visits in New York City. So we see that across different age groups and across all the boroughs in New York City. And we estimate, a quick estimate shows that about 44% significant increase in the asthma-related ED visits can be observed during this Wi-Fi smoke wave. And there has been many studies, including ours, showing that the Wi-Fi smoke-related PM2.5 is really a risk factor for not only respiratory illness, but also cardiovascular diseases and even mental health disorders. And speaking of this fine particulate matter, actually, over the past several decades, the environmental epidemiology field, or more specifically, the air pollution epidemiology field, has known very well that the health effects of air pollution goes beyond just the respiratory system. It can virtually impact all the organ systems. For example, some of our recent research shows that this fine particulate matter can impact our mental health disorders, can lead to increases in even cognitive decline and Alzheimer's diseases, and some particles that are smaller enough that it can goes into your body, that penetrate into the lung and it goes into the blood system, circulate around the body. They can also impact our cardiovascular system and our renal systems. So we have known for decades that this air pollution can impact the health. But this particular matter is very tightly linked to climate change, because air pollution and climate change, they are kind of the two sides of the same coin. They all from the burning of the fossil fuels. So when we tackle air pollution in the same time, we're also tackling climate change. So we can achieve the so-called co-benefits of climate change mitigation. But here, getting back to the health effects of air pollution, the impacts of adverse impacts from air pollution is not only from these particles. There are also other pollutants, what we call gaseous pollutants. For example, you heard of the carbon monoxide poisoning in your home, right? So that we know indoor, when the carbon monoxide goes up too high, it's very dangerous. That's why we need a carbon monoxide monitor in our house. But ambiently, we also show that a recent study, a global study, shows that the current ambient level of ambient carbon monoxide can also lead to significantly increased mortality across the world. And recently, the World Health Organization, for the first time, established the ambient carbon monoxide standard. Another gaseous pollutant that are closely linked to climate change is ozone pollution. And since this is the Yale Alumni Academy meeting, you must have been in New Haven during the past decades. And unfortunately, New Haven area, when it comes to air pollution, ozone pollution is the problem that we are facing. So ozone, like particulate matter, we have seen the adverse impacts on all kinds of different health systems. For example, one of our recent research shows that ozone exposure can lead to not only the total mortality increases, but also mortality from cardiovascular disease, respiratory illness, or the specific causes that we can observe. And the long-term exposure to this ambient ozone pollution can also lead to cognitive declines in older adults. One of our recent research shows that the particulate matter pollution in North Carolina can also adversely impact children's test score. So for all the children go to public school from grade 3 to grade 8, we assigned a fine particulate matter pollution exposure to them and look at their math scores and test scores. And what we find is that, as shows here, when the pollution levels goes not even as abnormally high as you see for the Wi-Fi, like 100 or 150, but the annual exposure goes above 8 or 9 microgram per cubic meter, you will see a significantly adverse impact on their math scores and test scores. So the current US EPA air quality guideline for the PM2.5 exposure is about 12 microgram per cubic meter. But as you can see here, this current air quality guideline is not stringent enough. So even the current considered safe standards can people living under this standard can still have significant impacts. And these impacts are not just for older adults, but also for our children as well. So these are all the epidemiological work we do to try to look at, the specific climate-related factors and the specific health outcome to see if there's a link between them. And when we have the exposure, when we know this exposure can adversely impact health, we can combine them to conduct the health impact assessment. So for example, when we look at the temperatures, we know that these abnormal heat and cold are linked to all the different system diseases. And we can then quantify how much of the mortality burden can be attributed to either heat and cold. So what we found in this study is roughly about 10% total mortality can be attributed to heat and cold, roughly less than 1% to heat and about 9% to cold. And if you look at the burden distribution, we see the majority are from these leading causes of deaths like stroke, like heart attack, hypertensive heart disease, or COPD respiratory illnesses as well. And it's not only about the average temperature. So when we see a cold day or heat day, we often see that the maximum temperature or the mean temperature exceeding a certain level. But sometimes we also see these abnormal temperature changes within a day or across a few days. So this, what we call temperature variability, can also have significant adverse impacts on mortality and morbidity. One of the recent example we published on this topic is we look at the African countries to look at the temperature variability and the low birth weight births. And what we find is there is significant association between the temperature variability and low birth weight. And we quantify this burden. We saw that about 7% of these low birth weight births can be attributable to these abnormal temperature changes within a day or a few days. So these are what we know historically the temperature, normal temperature can attribute to our health burden. When we look at air pollution, we and others has done a lot of work to try to understand in the past how much of air pollution can be linked to our health. And globally, the estimate right now stands about 6 to 8 million people died per year globally due to air pollution. If we zoom into the United States, and if you only look at cardiovascular mortality and this fine particular matter, what we find is that despite the fact that the past 2 decades we have seen less pollution due to the great efforts from the Clean Air Act in the US, we are still seeing a disproportionate distribution across the risk ethnic groups in the US. So when we look at the PM2.5 attributed cardiovascular mortality burden, we see that in the non-Hispanic Black group, they bear their health burden almost 3 times higher in terms of the cardiovascular mortality rate attributed to PM2.5. Higher, they are 3 times higher than the non-Hispanic white. And unfortunately, despite the PM2.5 reduction, this relative disparity between non-Hispanic Black and non-Hispanic white still persists today. But if we want to look at the future, we want to know, under the future climate change scenario, what are the impacts? So obviously, the first thing we need to know is the future exposure. So here, for example, if we want to project the future heat-related mortality and the climate change in Jiangsu province, China, we first need to obtain the climate change projections for the temperature exposure and the different climate scenarios. And then we can couple it with the epidemiological findings. Here is the exposure response function we get. Then we can quantify the future health burden under a moderate emission scenario versus a high emission scenario. So undoubtedly, we have seen that if we continue a high emission scenario pathway, we're going to have way more heat-related mortality burden in the future. But more interestingly in this study is that we see that there's an urban-rural disparity in this. So in Jiangsu province, unlike other developed countries, the rural areas, people living in rural areas tend to have a higher mortality risk due to the heat. So when we look at the future, it turns out that this kind of rural residents, they will have a much higher heat-related death burden in the future. And in calculating this, I want to mention that there's a large uncertainty. And one of the biggest uncertainty is actually from the climate model you're using. So here in this example, we're using more than 20 different climate models. And as shown on the left side, you can see that it depends on which model you're using. The actual number could be a magnitude different. So this really illustrates, the uncertainties from the models. And also, if you compare the different future scenarios, that means which pathway our whole society is going to take. Are we going to have a high emission scenario, or moderate or low emission scenario? That also can determine how much of the heat exposure and how much of the heat-related health impact will be in the future. But in doing this kind of analysis, we know that climate is not changing alone, right? In the future, we have all the other things happening in our society. And one of the critical impact is our demographic changes. We are an aging society, and unfortunately, in the future, we'll see higher proportions from the older adults, not only in the developed countries, but more concerningly, it's in the developing countries. The threat from this is that through the epidemiological findings, we know that older adults, they tend to be more vulnerable during these extreme weather events and during the high air pollution episodes. So when you look at the future, although you will have a warmer summer, you might have some less cold winter. So people may argue that, okay, in the future, you have some adverse impacts from heat, related mortality increases, but on the other hand, you might have declines in the cold-related mortality benefits. So if you consider that in certain scenarios, you might have large reductions in cold than the increases in heat. However, we argue that if you consider population aging, because the whole population is tend to be more and more vulnerable in the future due to aging, then what we see is that no matter which social economic scenario we are considering, the future heat and cold related mortality gonna be increased consistently. And we have seen this evidence not only from our published research in 2019 in Germany, but also in a recent accepted manuscript across 50 countries or areas in the world. And when we're projecting these health impacts, that the more and more factors need to consider. For example, how do we model people's vulnerability in the future? Are we going to better adapt to the future? And our current estimation shows that actually the social economic adaptation is more critical in the future. So this is actually a good news, because it means that the heat exposure we see and we're going to see in the future, they are preventable, right? So if we can improve people's social economic conditions, we can dramatically increase people's resilience, the population resilience to heat, and then reduce the health impacts. And if we look at the air pollution, I mentioned ozone is a particular linked to climate change. That means that when climate gets warmer, typically you will have a high ozone pollution. And because ozone also linked to the health, so we actually see a health penalty from climate change. That means even we don't emit more ozone pollution from our factories, from our cars, because of warmer climate, there will be increased ozone and thus increased ozone-related mortality. And it makes worse when we consider population aging. Aging population will dramatically amplify this ozone-related mortality as well. So what we can do? If you recall all the numbers we studied here, it's middle century, by the end of the century. And these numbers did not motivate a lot of people because they feel this is too distant, right? However, the COVID-19 pandemic has taught us that if we actually act on the carbon emission, act on the air pollution emission, we're going to see immediate reductions in air pollution and immediate health benefits. So this figure shows that in the beginning of the COVID-19 pandemic, the Wuhan first initiated a lockdown, and then throughout China, you have restricted lockdowns in China to limit the traffic, to mobility and traffic emissions. So immediately we see traffic emission related marker called nitrogen dioxide, the concentration is dramatically reduced. And we did some quick analysis showing that due to these COVID-19 lockdowns in early 2020, there has been thousands of people, thousands of mortality could be avoided due to this COVID-19 lockdown. So in other words, we see immediate health benefits from the COVID-19 lockdowns. Does that offer a good solution? Well, obviously we cannot let the whole world go to lockdowns to address climate change. And let alone we see over the past few years that in 2021, in 2022, the carbon emissions has rebounded. And the current data shows that the 2023 global carbon emissions exceeding the previous 2019 emissions as well. So in order to get a more sustainable and a more healthy way to address climate change, what we can really rely on is to reduce the greenhouse gas emissions by using more clean energy and sustainable energy, by phasing out the fossil fuels. And in the same time, we need to reduce people's vulnerability and increase the resilience to climate change. So mitigation and adaptation. So these are actually the two solutions we have, and we can't miss it. So in summary, what I've shown is climate change is happening, and it's through these extreme weather events and then worsening air pollution, it can impact a variety of health outcomes. And these adverse impacts from climate change is going to be amplified by our existing health disparity, our existing aging trend in the future. And to address the biggest health threats from climate change, mitigation and adaptation will offer us the solutions to tackle potentially the biggest public health opportunity for us in this century. So with that, I would like to thank you for listening, and especially shout out to the research group at the Chen Lab at the Yale Center on Climate Change and Health. Thank you.
Thank you so much, Dr. Chen. I'd like to remind everyone to please submit your questions in the Q&A box, and we will begin with the questions that were submitted during your talk. Rega Sota would like to know, based on your experience, what is the most challenging aspect of quantifying the health impacts of climate change?
Thanks very much. So this is a $1 million question. So one of the challenging part in quantifying the health impact of climate change is that we conceptually know some of the impacts, but we don't know quantitatively. For example, the flooding study I just showed. So we know flooding can lead to some of the health adverse impacts, but we don't know globally what is the health burden attributed to flooding. So because you don't know, then the health cost were not calculated. So I think this is one major kind of obstacle to getting the full health impacts from climate change. And the reason behind that could be, first of all, either it hasn't been studied. Second of all is because there's no data, especially if you look at a lot of low and middle income countries, they don't have some of the high quality health data as we have in the United States or in Europe. So if you want to study, for example, the hospital admission data in Africa, you probably won't get a full nationwide very good quality data there. Then if there's no data, then it's very hard to quantify the burden. So I think the data is another issue. But the third is we really need more and more funding on this because historically this has been a severely underfunded study area. Without much funding, we don't have many talented people in this field to work on this. But with the climate movement, with the more and more interest from the general public, from the students, are all energized and super interested in this. I think this will issues will be solved in the future, in the coming years, and hopefully we are not that behind. But the other thing I want to mention is that although we don't know the full number, it is I often call the true health impacts of climate change. What we know now is only the tip of the iceberg. But like in the movie Titanic, if you are the captain on the ship, if you see the tip of the iceberg, you need to change your directions. So as a society, although we only see the tip of the iceberg of the health impact of climate change, we need to shift, change our trajectory to reduce the carbon emissions and to better protect our people from climate change.
Thank you very much. This question is slightly related, but what are some of the barriers to accurately attributing mortality and morbidity to climate change when there is an extreme weather event, instead of simply, saying, died of a heart attack? How do you relate that back to climate change and get the people who are, filling out the death certificates to report these accurately?
Yes, that's a great question. So one of the things when we say death certificates is if you look at it, how people calculate this, especially due to extreme events, heat particularly, the physicians are not, when they put the numbers, when they put the diagnosis, it's really hard for them to say, there's a patient come here and died of heart attack. How do you know it is directly linked to heat, right? So that's why if you just rely on the death certificate, although there's a category there, but it's a very severe underestimation of the true impacts. So what we here rely on is through a statistical approach. So we rely on epidemiological methods like the time series analysis or case causal designs that statistically we can estimate for the population that during these extreme hot days, how much of this abnormal high mortality count can be attributable to the heat. And likewise, we do that for other extreme weather events as well.
Thank you. Our next question is from Ava Zickner. She says, to my understanding, neighborhoods with higher air pollution tend to be located nearer to industrial areas, and unfortunately tend to face lower socioeconomic status and other disparities. How do we know if air pollution and academic performance is a causal relationship or correlated?
That's a very good question. So in our particular study, what we did there is we try to answer this causal question by utilizing causal inference approach, particularly that is a quasi-experimental design to try to give us a quasi-experiment of the exposure is kind of randomly assigned. Then you have your when you have the exposure randomly assigned, we assume these are whatever the effects we observed after you controlling for all the other factors, we're gonna see close to causal impacts. So that's for that particular study because we really care about the question you're asking. But in general, so the low socioeconomic status, this kind of issue is true. This that we see the disparities in the exposure, like you just mentioned, people with low income or people in the Hispanic or Black neighborhoods communities, they tend to live close to the pollution sources, so they have a high exposure. But in our studies, what we try to add on to that is that it is not only because these people have high exposure, they are all in the same time also more vulnerable. So you have high exposure, but also more susceptible, more vulnerable to this exposure. That means for the same unit of air pollution, you actually have a high risk for these low income and communities of color. And the reasons could be also, if you look at their baseline health status, these communities could have suffering all the other problems. For example, some maybe higher prevalence of chronic illness or less access to high quality healthcare. All these things can also make them at the baseline a more vulnerable population. So then if we couple with high exposure and high vulnerability, no doubt you will have a high health burden for these communities. So I think it is one of the key topic in this field, how to address health disparity and how to first establish the causal relationship. But second of all, more importantly, is how do we design the policies, the measures to mitigate, to reduce, eliminate these disparities.
Thank you. Lauren Summers is asking, has climate change communication caught up to educating the general public on their risk factors related to climate change events like heat variability and flooding? Things that you've pointed out which are less obviously direct threats to our health.
Yeah, so I think that's why I say this invitation. I think that's a great opportunity. I think also the Yale communication program has doing a fantastic job in conveying all the different new studies from adverse health impact of climate change. Our center also are motivated to share our new findings on this topic. So we try to one thing I often tell people is that what we hope is that when people see these, for example, extreme weather events like wildfire smoke, people are not only responding to say, hey, there's orange sky, oh, let's take a picture, and then carry on with their normal life. We want to let the general public know these extreme weather events, these climate-related exposure, they are really deadly. They are really have significant health risks, not to your future generation, but to all the people affecting our health, our loved ones' health. So we should really take precaution measures. So we should really act now rather than just, oh, there's a flooding event and make sure my area is not flooded, then that's fine. Or just we need to take really measures now.
Thank you. Sarah Lawrence is asking, do you know any demonstratively successful examples of employing community health workers to help mitigate challenges specifically exaggerated by climate change impacts?
This is a very good question. I don't have such research experience with that, but I do know, for example, when we talk about, like, let's say heat exposure, one of the I think in some literature shows that to be particularly helpful is for these local health workers to go to see these older adults that are living alone, that nobody are taking care of them, or neighbors taking care of each other. So one of the things that making older adults more vulnerable to heat is they also tend to have different perspectives during extreme heat. So some older adults may not even turn on the air conditioning if they have during the extreme heat. So I think a lot of these local health workers can really be the game changer in conveying the message to let people be aware and then take the according precautions. So this could also lead to, for the Wi-Fi, let people know it's not only about the orange sky, that you should really have your air purifier working on, or if you don't, use your N95 masks when you go outside.
Jennifer Dumond is asking, what can we do at the point of healthcare as healthcare providers to prepare for and mitigate the impacts of climate change?
Thanks, Jennifer. This is also a very great question. So we at the Yale Center on Climate Health has a dedicated program for healthcare to address climate change, especially to mitigate the carbon emissions from healthcare. That was led by Professor Jody Sherman, and she was she's one of the leading expert on this. Actually, she contributes to a report called Lancet Countdown on Health and Climate Change, contribute to an indicator to tracking the carbon emissions from the healthcare sector. And the numbers has actually shown that, for example, the US healthcare sector alone contributes to, I think the number is about 5 to 8% of the total carbon emission. So it is a big problem, and there are ways that the healthcare itself can help reduce its own carbon emissions. And I often hear the program and also other people working on this area saying that do no harm is the first oath doctors and physicians take, but by emitting more and more emissions, we are actually violating that oath. So how to better address that? This is actually one of the key areas identified by the current administration, and in the US and also in the UK, their health departments are making the healthcare sector emission reduction as one of the priorities.
Thank you, Dr. Chen. I think we have time for one more question. Karen Whitehair would like to know, how do we communicate this research to the general public in such a way that they will not push back or shut down, but be encouraged to act positively to address the issues that we've revealed?
Thanks, Karen. I think, this is an excellent question. I think when we communicate the findings on climate change and health, the first thing I think we need to change is that climate change, the image people first think of, should not be polar bear. It's too far away, too distant. It's not it's not, quote unquote, people think, oh, it's not our business. It's not affecting us. So the first message we should convey is climate change is happening, and it's adversely impacting not other people's health, but our health, our children's health, our parents' health, our loved ones' health, my own health, my heart health, my mental health, my kidney health. So these impacts are not just about someone else, it's about Earth, right? So I think a lot of these events happening this year, the Wi-Fi events happening in the East Coast, reminds everyone is that it's not a West Coast thing. Actually, we have other studies showing that despite these extreme high-level episodes, when the Western or other areas burns, they can also travel thousands of miles. And it's also not only just about the big wildfires. Some small forest fires can also impact. And our study and other studies has shown that there's a substantial health burden from these Wi-Fi emitted particles for the east part of the US people. It's just, people didn't think of when they didn't see it. But so these are the things I think we want to communicate it to people so that they know this is actually about their own house. And that house are damages and benefits. And that benefits what we act on, for example, the 1.5 or 2 degrees Celsius, the Paris Agreement. It's not only about the Paris people but also about Pittsburgh people, but also about everyone here in your family. And it's not only about 50 years later how the people will feel or how the house will be. It is about today. And we see that evidence clearly through, if you didn't see it before, you see it from the COVID-19 lockdowns events.
Thank you very much, Dr. Chen. On behalf of all of our attendees and the Yale Alumni Association, we thank you for joining us this evening. Thank you for giving us such useful data, as well as encouraging us to advocate for ourselves and in our own communities. I hope that we can see you again in the future. And for everyone listening, tomorrow our conversation is on changing hearts and minds and guiding strategic discussion. I think that that will be a wonderful follow-up to Dr. Chen's conversation. Thank you all and have a good night.
Thank you, everyone. Bye.